In this video, we'll look at the classification of matter. Now, we've already learned what the different states of matter are. Next step is to figure out how to classify our matter. When we classify our matter, we can classify it as a mixture or a pure substance. In the mixtures, we can also classify it as either a homogeneous mixture or a heterogeneous mixture. If it's a pure substance, we can classify it as a chemical compound or an element. And we're going to examine all these different ones a little bit closer. So first, looking at kind of that top layer, we know what matter is. Matter is any substance that contains space and takes up volume. But that matter can be dictated as either a pure substance or a mixture. If it's a pure substance, it contains only one kind of element or compound. Examples here can either be all these green ones would be a pure substance, or all the purple ones by themselves would be a pure substance. If it's a mixture, those green and purple ones are mixed together. So it's composed of two or more different types of atoms or molecules. The proportions of it doesn't matter. As long as it's two or more different types, it's considered a mixture. Now, looking at the pure substance. With our pure substances, we can either have them as elements or compounds. If it's an element, then it consists of only one type of atom. It can't be broken down into simpler substances. It can't be broken down into simpler atoms. So examples of my elements, if I had helium all by itself, that would be a pure substance. Even oxygen, even though oxygen comes to O2, that would still be a pure substance because it's just oxygen. Example of a compound, if I have water. Compounds are substances that are made of two or more elements. An example of a compound would be water. Water contains two hydrogens and one oxygen. Since there's two different types of atoms here, it's considered a compound. Now, compounds can have more than two atoms. You can have very complicated compounds. Example of that could be your DNA or RNA. That would still be considered a compound. And if it's just DNA by itself, it would be considered a pure compound. Looking at a few examples of our elements versus our compounds. For elements, you can have a single atom by itself like this. Examples could be helium, neon, argon, kind of most of our noble gases there. Then we can also have molecules of an element. Those would be ones that come as two atoms together. So that could be something like oxygen that we breathe, nitrogen that's in our air, hydrogen comes as two hydrogen atoms together. And then we also have molecules of a compound. The molecules of a compound, example on the other slide, we had water, could have ammonia, could have sugar. Sugar counts as a molecule of a compound. And then if we mix them all together, that's when we get a mixture, and we'll see those in a second. So kind of some examples we have here. We have gold. Pure gold would be considered an element. And a compound might be something like iron pyrite or fool's gold. You can see why they call it fool's gold because it has that shiny yellow luster like gold. But you can tell it's fool's gold because it comes as squares. It comes as cubes. Gold doesn't come as a cube. So now that we know a little bit about pure substances, let's look at mixtures. When we have a mixture that contains two or more pure substances. Our mixtures can either be homogeneous or heterogeneous. A homogeneous mixture has the same composition throughout. A heterogeneous mixture, it's not the same throughout. And let's look at a couple examples of these so we can really see the difference between homogeneous and heterogeneous. When we look at something homogeneous, it has the same proportion all throughout. Basically, it's uniform throughout the entire substance that you're looking at. Examples, the air you breathe. When you look at the air you breathe, there's not more oxygen in one corner of the room versus the other. It's consistent throughout the entire room. It has the same proportion of oxygen in the entire room. If our substance is a liquid and it's homogeneous, we call that a solution. So examples of homogeneous liquids or solutions could be coffee. Coffee is the solution for lots of things in the morning. And if your solution is made from water, where water is the solvent, water is the one in the highest proportion, then we call it an aqueous solution, special kind of solution. Example could be if we took our copper sulfate here and dissolved it in water, now we have a solution. We have an aqueous solution because we dissolved it in water. So when something's homogeneous, it's uniform throughout. It's consistent throughout. You can't tell different parts of it from each other, which is the exact opposite of our heterogeneous mixtures. For a heterogeneous mixture, they have different proportions and different mixtures throughout the substance you're looking at. So examples, if we look at a granite countertop, you can see there's different proportions of compounds in there. Between the black ones and the beige ones, those make different colors. There's different elements and different compounds that make those different colors. You can see it's very obviously not uniform throughout. Another example, if you wanted to make your coffee extra fancy, you can get a latte, and you can see there's different proportions of milk to coffee there. The darker parts have more coffee, the lighter parts have more milk. Pizza could be another example of a heterogeneous mixture. You can tell the different parts of pizza with the different toppings. For in chemistry, a heterogeneous mixture might be if you had a liquid that didn't have a solid dissolve all the way. So you'd have your beaker with a little bit of solid on the bottom. Or you might have your beaker and have two liquids that don't mix together. So if you think about if you have oil and water, they don't mix together. Or you can think oil and vinegar. It doesn't mix together till you shake it really, really, really hard. And even then it'll start to separate out again. So those would be examples of different heterogeneous mixtures. So now you guys should be able to classify your matter.